In this video, we'll be solving basic linear equations as well as basic linear equations that happen to have fractions. In this case, we're going to have to make sure we pay very close attention to our order of operations, again, PEMDAS, or parentheses, exponents, multiplication and division together, addition and subtraction together from left to right. Now in this equation you'll see that we have 4 plus 3 parentheses x plus 2, which means that this 3 is multiplied by this entire set of values equals to 13 minus 3 times this entire set of values. Now one thing that is most commonly mistaken is the fact that this is a technically 13 plus a negative 3. So that this negative 3 has to be distributed to everything here. So when we see a negative in front of a number in front of a set of parentheses, we must distribute that number to all the terms inside that parenthesis. But if there's a negative, we must distribute that negative to all terms. So very carefully, this is plus a negative 3 times x, which will end up being a negative 3x, and a negative 3 times 7, which will end up being a negative 21. Now that we've dealt with all the parentheses, and when I say parentheses, I'm specifically referring to, I needed to look inside, was there anything to simplify for parentheses inside? There's no exponents anywhere in this problem, so I will then move to multiplication and division. This 3 is being multiplied by this entire object, so by multiplying the 3 into those two terms, I'm taking care of the multiplication step of PEMDAS. Same with this negative 3 being distributed in here. At this point, on one side of the equal sign I can combine all these like terms, on the other side of the equal sign I can combine all these like terms. So over here I'm going to have 3x plus 10. And on this side over here, it's going to be negative 21 plus the 13. I'll put the negative 3x first, and then end up having, looks like, a negative 8 left over. At this point, when I'm combining like terms now, I'm combining across the equal sign, which means that I have to actually move the entire term from one side to the other. Now, I always prefer to have my x's positive, so I will add the 3x to both sides, as opposed to subtracting this 3x to this side. So this will cancel out, and I'll be left with 6x plus 10 equals to a negative 8. And again, don't forget that this subtraction is going to behave like a negative. The way that that is necessary, because this is subtracting 8 from this entire thing over here. By removing this entire thing, it doesn't mean that that negative disappears. That negative must stay in front of that 8 until that 8 has been dealt with. My next step is I'll be subtracting the 10 from both sides to get my x's all by themselves, giving me a negative 18 equals to 6x. And to get x by itself, finally, I will divide by 6, giving me x is equal to a negative 3. Now, in almost all cases of equations, what we should do is we should be taking this number, we should be plugging it back in up here for x and checking to ensure that it works. Now, I know that if I did the math correctly, I will not need to check this. But there are some equations that are absolutely necessary that we check. Again, a linear equation is not one of them. However, to ensure that you did all the math correctly, and there's no mistakes in any of the steps, we should plug this in and check it. So, 4 plus 3 times a negative 1 equals to 13 minus 3 times a 4. Now you'll notice here the first step that I took was, again, PEMDAS, parentheses. I actually simplified what was inside the parentheses first. There's no exponents, and then I moved to multiplication and division. So the multiplication from left to right, I'll deal with this 3 times a negative 1. So 4 minus 3 is what I'll end up having there, equals to 13, and then again it's negative 3 times 4, which is then going to be a negative 12. So when I combine like terms here, I get 1, and combine like terms here, I get 1. This checks my answer, and therefore x equals negative 3 is a valid solution to this linear equation. The next example we'll be looking at is going to be, again, rational equations, but it's not exactly a rational equation. It's more of a linear equation with fractions. The reason why this is a linear equation with fractions and not actually a rational equation is because the equation will look like this: x plus 2 divided by 4 minus x minus 1 over 3 equals to 2. Now you'll notice I put parentheses around these pieces. In most cases, they won't actually be given this way, they'll be given this way. But it's extremely helpful that we always use parentheses to emphasize what we're looking at. This is all one term. This x plus 2 over 4 is one entity, just as x minus 1 over 3 is one entity. This subtraction right here says I'm taking this entire fraction minus this entire fraction. Now, to deal with these problems, generally what we're going to want to do is we're going to want to figure out what the common denominator is. In other words, we're going to want to figure out what what value in the denominator is singularly separate from all the other denominators. So I'll take this one right here and I'll look at it, and 4 is the same thing as 2 times 2. So that's going to be part of my common denominator in the grand scheme of this problem. I'm then going to look at the next denominator, and you'll notice that this has a 3 in it. I'll also identify the fact that this 3 is nothing in common with 4. So for us to get a common denominator, I would need to multiply by a 3 here. So that means my common denominator would end up being 12. Now the reason why I didn't look at this 2 over here is because in reality this 2 is going to be divided by 1. And again, if it helps, we can throw parentheses around to make sure it's very clear that this is a separate term. But this 1 isn't going to affect this common denominator at all. So even though this is a whole number, it can be written as a fraction, and by writing it as a fraction, it doesn't change the common denominator. Now, the way that I like to phrase the common denominator, especially in solving problems, again, anything that has an equal sign and a fraction in it, is that I will take this common denominator, I have picked it very specifically so that when I multiply both sides of the equation, and again, notice how I'm circling this entire side, and this side of the equation, by that number, I will be able to cancel out all denominators. Okay? Again, the common denominator allows me to multiply by this number on both sides of the equation. I can't multiply willy-nilly one singular piece. I have to multiply every single thing in this equation by 12. Then things will start canceling out. Now, in this case, I'm going to leave this common denominator as written times 4 times 3. And the reason I'm going to leave it written this way is because if I were to write this 4 times 3, I'm going to multiply this first term by that. Again, I don't want to forget, I'm going to multiply the next term by that. And finally, I'm going to multiply the last term by that. Now again, I'm multiplying both sides of the equation by 12, or multiplying both sides of the equations by 4 times 3. Now, what will happen is when I multiply 4 times 3 times this fraction, this is technically supposed to be multiplied across the top of this fraction. Technically, I'm multiplying by 12 over 1. And when you multiply two fractions together, you multiply across the top, you multiply across the bottom. However, because this is 4 times 3 times a quantity x plus 2, and it's all divided technically by 4, the 4 on the top of this fraction can cancel out with the 4 on the bottom of this fraction. Now keep in mind, you're not allowed to do this over additions or subtractions. So for instance, this 3 being multiplied by this x plus 2, with a subtraction sign separating it from this 3 over here, I can't cross out this 3 with that 3. However, over in this term, again separated by a subtraction and equal sign on both sides, this 3 can cancel out with this 3. This will then leave me with 3, and again, this is why the parentheses are so important, 3 times x plus 2 minus 4 times x minus 1 equals 2, and then it's 2 times 4 times 3. Now there's no distribution occurring here specifically because of this multiplication sign. Yeah, there sure is parentheses, but again, arguably when we do PEMDAS, it's 4 times 3 is 12, and then times 2. Again, we do inside the parentheses first, so I'm going to do 4 times 3 first, and then multiply it by 2, getting me 24. At this point, you'll notice that this example, this equation, actually looks very similar to the last equation we looked at right here. It is simply a linear equation. So this is, again, a fractional equation, a linear equation with fractions, that when I remove the fractions, I'm just left with this simple linear equation. Now, because I'm running out of paper here, we're going to move this over to this side. When I distribute the 3, I'm going to end up with 3x plus 6. Here, when I distribute the 4, don't forget that I'm distributing a negative 4. If it helps, change this to a plus sign and change that to a negative symbol as opposed to a subtraction symbol. They are the same, arguably, but they treat differently. So what I'm going to do is I'm going to chuck this in parentheses. It is plus a negative 4 times x minus 1. So I'm going to end up with a negative 4 times x, which is negative 4x. I'm going to multiply negative 4 times a negative 1, adding 4. This is all equal to 24. And then I will simply go ahead and combine like terms, giving me 3x minus 4x is negative x. 6 plus 4 is 10. And the reason why I'm allowed to combine these terms and I don't have to subtract things over is because all these terms are on the same side of the equal sign. This is all equal to 24. And again, in the last example, I argued that I'd like my x's to be positive. Well, in this case, it's going to be a lot easier for me to subtract the 10 over and then multiply by a negative, rather than me adding the x, and then subtracting the 24. Can you do it both ways? Absolutely. There's nothing wrong with subtracting the 10 and then multiplying by a negative. There's nothing wrong with subtracting the 24 and adding the x. In both cases, you should end up with x equals to, looks like, a negative 14. And again, once we get x equals negative 14, we should take this number, plug it back into the original equation, and check that it satisfies the equation. I'm going to go ahead and do that relatively quickly by chucking in that number and simplifying at the same time. In this case, I'm going to end up with a negative 12 over 4, which is a negative 3. In this case right here, I'm going to have subtraction of a negative 5, and therefore I get 2. Yes, a negative negative is a positive, so this would be negative 3 plus 5, which gives me 2.